Today's objective is to understand matrices. A matrix is a rectangular array of numbers. It is a way for us to organize data, and this data is numbers that are lined up in rows and columns. A matrix is described by its dimensions. A 3 by 5 matrix, for instance, would have 3 rows and 5 columns. A row is a horizontal numbers, and the columns are the vertical numbers. A point in position 1, 3 would be in row 1 and column 3. For instance, the matrix A has a row of -3, 2, 5, 7, -1, and 4, and row 2 of 5, -1, 8, -4, 6, and 2 would have what dimensions? Hopefully you see that it has 2 rows and 6 columns, so the dimensions would be 2 by 6. What number is in position 2, 5? Well, that would be row 2, column 5. So if I go down to row 2 and count over 5 spaces, I am at position 2, 5, which is the number 6. Example number 2. Let's say, for instance, matrix A has a dimension of 3 by 4, and matrix B has dimensions of 3 by 4. Since matrix A and matrix B have the same dimensions, we can add or subtract the matrices. To find the sum or difference of these matrices, you add or subtract each corresponding position in the matrices. For instance, position 1, 1 in matrix A is added to position 1, 1 in matrix B. If the dimensions of the matrix are not the same, the matrices cannot be added or subtracted. Example number 2. Matrix A is a 2 by 4 matrix. Row 1 is 1, 3, -4, 6. Row 2 is -2, 0, -3, 5. Matrix B has row 1 of 0, -2, 5, 3, and row 2 of -3, -1, 7, 3. So if we want to add matrix A plus matrix B, we would have 1 plus 0 to equal 1, 3 plus -2 to equal 1, -4 plus 5 to equal 1, and 6 plus 3 to be equal to 9. In row 2, -2 plus -3 is -5, 0 plus -1 is -1, -3 plus 7 is 4, and 5 plus 3 is 8. If we are going to subtract matrix A minus matrix B, we would have 1 minus 0 equals 1, 3 minus -2 is equal to 5, -4 minus 5 is -9, and 6 minus 3 is -3. Excuse me, not -3, +3. Row 2, -2 minus -3 is 1, 0 minus -1 is 1, -3 minus 7 is -10, and 5 minus 3 is 2. Again, the reason that we can add or subtract matrix A and matrix B is because they have the same dimensions. Example number 3. Matrices are a good way of displaying data. As an example, we have a chart that has the continents of Africa, Antarctica, and Asia, with the high temperature of each continent being listed and the low temperature of each continent being listed. This data could be arranged in a matrix such as 156, -11, 59, -129, 129, and -90. Thus, each row represents the continent. Each column represents either the high temperature or the low temperature. The matrix was used to help build the first computer. The computer was designed through a series of switches arranged in a matrix. Each position was numbered either 1 or 0. 1 represented a closed path and 0 represented an open path. Early computers had matrices looking like the following. And then there's an example with all the switches listed below. In summary, a matrix is a rectangular arrangement of numbers. This matrix is described by its dimensions. Each dimension represents the number of rows in a matrix or the number of columns in a matrix. A 1 by 3 matrix has 1 row and 3 columns. Adding and subtracting matrices can only take place if the dimensions of the matrices are the same. The mathematical operation is then performed on each corresponding position. Hopefully that gives you an idea of what matrices are and how they can be used in organizing data and then performing operations on them. Hopefully you'll be able to now complete problems 3 through 22 on page 456.